Okay, class, here is the second part of the review. I'm just going to go through this really quickly so that you guys can get the answers and study them for tomorrow's test. First one, number 18, says, what is Thomson's raisin pudding model of the atom? What is the advantage of this model over Dalton's? So here's your raisin pudding model. And the advantage over Dalton's model, remember Dalton's model was rigid, spherical. Thomson's model had the electrons on it, so it showed those, and that was the advantage of showing the other parts of the atom that Dalton didn't account for. Number 19, how did Rutherford test the raisin pudding mode of the atom? Draw a picture of the apparatus. Okay, so here's your gold foil experiment. So this is the cathode, or where you shot the alpha particles through it. And you can see that some particles went through, others bounced off because of those alpha particles hitting the positive nucleus in the gold atoms. And so that's that picture that's in the notes. 20, what were the results of Rutherford's experiment, and what did he discover about the vast majority of the atom? Well, he discovered that the mass majority of the atom is empty space, and the nucleus is a dense center of it. That's 1/100th of the size of the total part of the atom, and it's positively charged. All right, so 21. Where are the protons, neutrons, and electrons in Rutherford's model? They're all together. He didn't actually Rutherford's electron. He didn't know what was going on with the electrons, so that was a problem with Rutherford's atom. He accounted for the neutrons and the protons, but he didn't know what was going on with the electrons. He thought they were just spinning around, but he thought they were going to lose energy and go towards the center. So he knew there was something wrong that he just couldn't figure it out. So what is an alpha particle, and how did it help prove the existence of the nucleus? Alpha particle is a helium ion with that +2 protons on there. It's positively charged, and it's repelled when it hits the nucleus of the gold foil. But how big in volume is the atom compared to the nucleus? It's 100 times bigger than the nucleus. 100 times bigger. 24. How much of the atom's mass is contained in the nucleus? All of it. Because remember, electrons virtually have no mass at all. What is the difference between two isotopes of the same element? They have different masses. They have the same chemistry, right? Meaning that they have the same amount of protons and electrons in them, just the mass is different. 26. What is the difference in chemistry between two isotopes of the same element? Oh, there's no difference. There's no difference. Just one's heavier than the other. So their chemistry, meaning their reactivity, is going to be the same. 27. What are the two methods for separating two isotopes of the same element? And you can use a centrifuge or a mass spectrograph. That was on the notes. If there are two isotopes of Su-325 at 10% and Su-328 9%, what is the atomic mass of Su-3 that would be reported on the periodic table? Well, let me show you. Okay, so here is the problem worked out on this 3x5 index card. So we just put that up here. You're using that average atomic mass calculation. You had one of these on the pre-test quiz today. Formula is the abundance of 1 times the atomic mass of 1 plus the abundance of 2 plus, or this should be times, excuse me, the atomic mass of 2. And so you do that math. Here it is, 32.5 plus 29, 295.2. So the average atomic mass will be 327.7. And that's the final answer. Okay, so number 29, and this, if georgium was a real element and there was two isotopes of it, you have georgium 416 and 420, And the periodic table shows georgium to have weighed an average mass of 460.8. What is the abundance of the two isotopes? Well, this is a problem because there's not a lot of information there, so you have to deduce how to do this mathematically from that information. So basically, this is how you set it up. You get 416 times the abundance, we'll just call it A, because we don't know, of 1. So this is 416. Then you get 420 times the abundance, or 1 minus A, which is the abundance you got here, and equals the 416.8. Basically, you do the math here, and you end up finding out that 416 abundance is 80%, and the 420 is 20%. And it makes sense because this average mass is closer to 416, so that means there's more of an abundance of that. All right, number 30 is at standard temperature and pressure, what would be the volume of 3 volumes or moles of nitrogen? So you are going to set it up like this: 3.5 moles over 14 grams, because it's how much nitrogen weighs over 1 mole. So you're basically going to multiply that. Those cancel out. 49 grams of nitrogen. Somebody wrote that in there. I'm not sure what the deal is with that. Actually, I let some of the students borrow this. Here's your answer. Number 31, at standard temperature and pressure, how many moles will be contained in 4.48 liters of hydrogen? Basically, you got 4.48, and you get rid of the liters, the volumes here, times by a mole. You have to go through the mole to get there. And then it's hydrogen, so you know that the atomic mass of hydrogen is 1. You do that math, and it's going to be 4.48 divided by 22.4 times 1. You get 0.2 grams of hydrogen, right? Oh, I'm sorry, moles. This should be moles, not grams. All right, number 32, if to make hydrogen bromide, I need 1 mole of hydrogen for each 1 mole of bromine gas. How many milliliters of hydrogen would I need to react completely with 45.6 milliliters of bromine gas at the same temperature and pressure? So basically, it's telling you it's a 1-to-1 ratio conversion factor. So you do it, set it up like this: 45.6 milliliters of bromine, and you know you put your bromine down here. It's a 1-to-1 ratio. Basically, it's going to be 45.6 milliliters. Okay, so hopefully this helps you guys out. I hope you enjoyed this, and you can pause this video and go over some of the stuff that didn't make too much sense to you. Again, on the first video, I put some sites on YouTube that you can look at. So look at those. Maybe those guys can help you. Bozeman Science is good. And I can forget the name of the other kid that does it, but he does a good job too. And of course, Mr. Cosby. So hopefully everything goes good for you guys. Study hard and do a good job tomorrow. All right, guys. Take care.